We are going to share the story of our class. And of course, Jason will lead the way. But before I start, I want to say that we're very grateful for the opportunity to present our ideas here, and grateful to the Joel and UBCO studios, as well as we're grateful to be able to create these beautiful images that we'll share with you, and on unceded Okanagan Silks territory. And to begin, we will introduce the class and course objectives. Then Jason will take over and talk about the research, development, and production aspects of it. After which we will reflect on learning outcomes and learning experiences, reflecting on specific aspects that relate to Jason's work that was presented in the theater, and finally have closing remarks. So one day Joel came and said, "We have this great space. What can you do in there?" And that was such a fortunate opportunity for our class, because the advanced media class is really designed to provide experimental laboratory workshop type studio opportunities for students to create the artwork from the initial idea and through research and development to the final product. So when Joel and I talked first time, we saw what is a great opportunity for the class to have a real impact on the local UBCO community and be able to present their work. So we structured the entire class to work within that context. And I'm going to briefly go over the learning objectives. So it's really about refining self-directed studio practice. But of course, if you are designing an artwork or a media story, it's really important to have the real output, because that enhances the skills of critical and creative inquiry in the context of the public presentation. So we really were very fortunate to be able to produce our work in the public context, and even more importantly, in the public context of the university, because students live on the campus and there is a great community aspect building to it. And the students were extremely excited with the opportunity to show their work for their peers. I want to stress throughout our presentation, as you will see, as Jason will discuss the process itself, we have this amazing technology and amazing opportunity, but it's really the humans who make things happen. People like Joel, who was such a champion in enabling us to access this fancy technology, which typically is not very accessible for the students, and give us the opportunity to be able to work. So with that, I will let Joel explain, with that, I will let Jason explain our class process.
Cool. All right.
So, okay, well, I'm so sorry. I'm just going to play the video. Oh, there it is. All right. So we'll be playing the class work as we speak, because I think that's more engaging than seeing the words on the page. The first work we're showing, it's Losing Touch from Lark Spartan. Okay. And just make sure that the volume is down. And here we go, Jason. You can have
All right, great. Thanks, Alex. So this was an upper level art production class. So having a little bit more specific integration of artistic medium and themes is important. So we did start the class developing small scale sketches, quote unquote, based on research from writings such as environmentalism, mental health, whatever concerns were interesting to the students, really. Then we had our first tour to the Sawchuck Family Theater. This was more of a short tour to introduce us to the space and the specifics of the screen. Joel showed us a sample of work, and it became immediately clear just how large the screen was, and also just how public it was. So, that makes a couple of the students kind of nervous, but this is kind of the story of how that is overcome and how we've all made these really great works. While the Sawchuck Family Theater is in kind of like a cave of sorts, like a side room to the main hallway, it is very visible to the main hallway all the same. Essentially, the goal of the class, the goal of what the students would be making was very clear after this first tour. This was our canvas, this very large screen, and from that class forward, we started on creating prototypes, developing the beginnings of what would be the final work. There was a clear impact right away, in my opinion, of knowing the work was destined for this very public consumption and not just an art building consumption, because we're very used to us as the fine arts students presenting our work in the FINA gallery, but having our work elsewhere on campus is very different. That's a completely different audience. And the awareness of that changed the stakes of the class significantly. The work, it just becomes more than just being created for assessment by the professor, but it becomes sharing with a larger audience. As well, the experience of specifically creating work for a space, like a specific space, it's much more different than just creating work in a class separate from a specific space and then getting presented at the end in, say, a gallery space. Knowing the end goal very clearly allowed for the concepts and work prototypes to become more developed a lot faster than usual. Most students knew what they would be working on for the rest of the class by the end of the 5th or 6th week of class, if I recall correctly. Then we went to the development period from research. Every class we workshopped our work together in order to make it as strong as it could possibly be. This is usual in an art production class, but because this class was aiming for a single strong work in a single specific location by the end, there was a lot more iterative development. As a result, the works overall grew rapidly and were very strong. The one thing specifically I wanted to talk about was how the artwork created for a class that intends to exhibit publicly broadens the scope of the individuals. It created a high personal expectation for some students, and they rose to that challenge. The public situation of the screen raised the bar for the class. Having the specific early access into testing their work in the Sawchuck Family Theater helped with meeting their work expectations. Thank you, Joel. This is where we'll come to the first prototype presentation. So this was the first time we'd actually put our work on the theater screen, and something became very obvious. Many of us were working in 1080p, which is HD, and we thought that would be enough, but no. The screen, it's 4K, and it was very obvious that it was just too blurry, too pixelated, even if we were in 1080p. So we had to be working in 4K. Thankfully, we had that initial prototype presentations about 5 weeks from the final submission presentation, which provided a lot of time to reconsider and fix aspects of the student work. As per the course outline, there was only the prototype presentation and then the final presentations, but as a class, us students really wanted the work to be shown like as a second prototype presentation one more time, just before the final, in order to do some further troubleshooting. Thankfully, Joel was super duper accommodating and allowed for this to happen. There were further changes to students' work after that second prototype presentation. Overall, in this class, students were a lot more malleable to critique and feedback. The stakes were higher, so input was taken more seriously and utilized so much more efficiently and artistically. Then we were ready for the final presentation. By this time, the students had had the very valuable opportunity to play and present their work several times. So the final work that was presented worked perfectly for the immersive screen for the Sawchuck Family Theater, including figuring out all the audio technical problems that there were. Overall, my classmates and I were so much more comfortable presenting this work on such a large public screen by the time the final presentation rolled around. No one was particularly nervous at this time. And that was really thanks in part to the full integration of this class with this specific space. And I'm gonna pass the mic over to Alex again, and she can talk about the learning outcomes and experiences of her class.
Okay, Jason, feel free to jump in anytime you have something to add.
For sure.
As we go. So what this project really showed, or this collaboration, is that it's a kind of real world problem situation. So no matter which challenge we would encounter, whether it's the notion of resolution or the technology or the audio, we had a real world situation and high stakes to solve all the problems. So I think that's really valuable. And, but more importantly, enabling access to students to work on such a cutting edge technology is really preparing them for the future and for troubleshooting that this kind of technology requires to make excellent work. So I feel that we were able to really enhance our learning outcomes. But I also want to share one important point. In a class, sometimes we're looking at the bell curve. Some students do really good and some students don't do so well. The funny thing about our experience is that every student in the class created amazing work. So the quality of the work was exceptionally higher. In my experience as a teacher, doing this kind of work, this really made a big difference. Another thing that happened for students is that they were really proud of their work and the classwork. And they were really looking forward to exhibiting their work in this context. So much so that because the class created this work for this particular venue, everybody in the class agreed to have these videos as a part of the venue. So it's a really excellent collaboration. I wonder, Jason, do you want to add something on the learning outcomes and enhanced experience?
Sure. When it comes to the learning outcomes, there were a couple students that had not really done a lot of digital media work before. So by the end of the final presentation, they had really gotten a lot of problem solving done, as in how they could transfer their traditional media skills into a more like appropriate digital media. And a large part of that was that iterative work with the screen. We do have an example. Oh, I think you already showed it actually. Adriana's the one with the charcoal pencil, the stop motion one. Like, you know, she was working really small all semester trying to do digital work, but at the end of the day, it came to, oh, let's just do a large traditional work and utilize that in digital media. And that was really successful at the end. And she was super happy with that.
Yeah, it kind of forced students to find their strongest point and then share that with the UBCO community. But I do want to reiterate, in this entire process, what was the most valuable was the interaction and the support we got from our media studios, specifically Joel, in being able to build that, because that's an iterative process. And it really served students' learning and ability to access this technology. So in the sense of, even though our learning outcomes were, or learning objectives were, to create media artwork from the beginning to the end, to the final production, in my experience, because of the cycle of being able to develop in the context of the public space and being able to present in the public space, the quality of the work was much, much higher. So I will, at this stage, allow Jason to, what we were looking at, the last work we looked at was a seismic reversal by Jason Dennis. And I would like Jason to reflect a little bit on the work and what it meant to Jason personally to develop for such a large work.
Yeah, if you want to play it again, that might be useful. We don't have to play it the whole way through again.
Okay, we'll play it as you speak. Okay.
Yeah, just so that you guys know what I'm referring to and stuff. So I guess a brief background on my work. As was mentioned by Joel, I'm an MFA student. Master's of Fine Arts, graduate student, and my work is deeply personal. As my research and artwork production, it directly deals with gender transition and the event of a familial loss early on in that. The idea behind seismic reversal is that my state of being in gender transition did not exist at the same time as my sister did, as she died quite early on in that process. The idea is that the cycles of life and death are in continuous motion, and that they, in this case, are simultaneous in both directions. So that's why it goes back and forth. So this is a really personal work. There is a tendency to present personal media small, but this is a reaction based in uncertainty and nervousness, in vulnerability. But you need to expand beyond that for both the sake of the artwork and the sake of the work's meaning in the world. And working large in public can really aid in that process of coming out of the proverbial artistic shell, if you will. Creating this work for the Sawchuck Family Theater large screen, immersive screen, basically propelled these concepts forward in a way more driven and concise way. You grow much more rapidly as an artist, in my opinion, when you must work large, but most importantly to the experience in this class, the ability to test the work consistently and try different formats was integral to develop the work in a way that had greater communication between the public art presentation and my intention. Originally, this work was 10 minutes long instead of 5, so it was a lot slower. But for the purposes of this class presentation, for the presentation on that immersive screen, the 10-minute version was way too slow and too subtle to be properly communicative with outsiders for the public viewership. Because you could walk by and you wouldn't not even notice that it was actually moving, really. The experience with the immersive screen, in this sense, was very helpful in the development of my thesis work, this specific work. And I'm just super thankful for the opportunity to play with this immersive screen. That's all I gotta say about that.
Okay. So we would like to play 2 other works that have a really strong audio. So yeah, let's play them first and then we can just conclude. Okay, and the last work. So for example, in multimodal landscape, Emerald Holt created all the animations as well as original music composition. So it's rather impressive if you think about a very short development cycle. And so to conclude, from our experience, it's really lovely to have the public spaces in university, that they're really important venues for sharing ideas and deeply meaningful. But the most important thing I feel, whether and how we judge the quality of the work, which from my perspective and my experience was much higher than in a normal and a typical scenario where the public presentation is not there. The fact that we got access and support as a class is the most meaningful aspect of this experience. And both myself and the students were actually very happy and very proud of the results. So I'm very grateful to for this opportunity to work together. I'm really looking forward to doing more experiments after we get back into the physical space. As a matter of fact, some of the future work would include us developing potentially some of the interface, coding interface, to be able to maybe take these screens over and make an interactive artworks and see how far we can push as artists and developers, how far we can push the interaction with the big screen as such. Jason, do you want to add any closing remarks?
Yeah, I mean, I think that sounds great. I mean, I know we've been praising Joel throughout here, but one more big thank you for him because he spent a lot of time with our class, like hours and hours helping us out. And that was really cool and very integral to the growth in allowing these students, myself included, to have the work on a really big scale for once instead of kind of smaller or just in the FINA gallery, for instance. So
and unfortunately, I don't think the Zoom is cutting it to show this work. It's just a simulation of that real physical presence.
Yeah.
So thank you so much.
All right. Thank you.
Thank you so much, Alex and Jason. That was a trip down memory lane. As we said, this was in 2019, and we were scheduled to do a reception and a showcase of all this work. And then unfortunately, due to some technical maintenance on the wall, as it was, we're still learning about it. We had to replace some panels, so that delayed it. And then we eventually ran into, I believe, holidays, and then some sort of pandemic kind of happened to slow down even further. So we really haven't had a chance to give this media the time that it really deserves in that space. But I hope to do that soon, and looking forward to upcoming opportunities to work in that space together. There are a few questions, Alex, if you and Jason would care to maybe kind of answer these.
Sure.
The first one is, did the class collect and review feedback from the theater visitors? If yes, could you share some interesting and memorable comments?
Not really formally, but I feel that as we were hanging out in the corridor and showing the work, people would come by and would be impressed. So we got lots of great cheers from other faculty, from other students, but also from people in the library, because it was a real showcase of what we can do as a community, or at least a seed, if nothing more than that.
Yeah, nothing official, but there was a lot of people just hanging around on our final presentation day, not just because we had snacks on the table, but to actually look at the work too.
And laughing and being happy that the students, building for students and for the library. The library is the heart of university, so it's about the best space you can get the entire UBC community.
Has COVID changed the content of your creations? Has it pushed you in a different way, or are you staying mostly the same?
Not sure.
Well, we're discovering other modes of being, and like my current class, one of those third level classes in media, we're using JavaScript and open processing. So we're web only. We had great plans to develop tools to be accessing the media screen, and we were going to do this September and look at how we can take over the screens and create something even more immersive and interactive. But of course, now we're all in the web and JavaScript world. So yes, it did change, but the web is a kind of public space. So definitely change. And for that, it's really important to have the right tools to be able to develop as a class. So we have been using open processing environment to do some great development. But of course, it's all virtual. It's all virtual, and the physical contact and exploration as a group in the physical space is not something we do these days. Big change. We had to change the tools, we had to change the programs just to make things work for our experience right now. Yeah. Big change.
Group gallery shows are a little bit more difficult to do right now, much less having the celebrations about a class presentation. No more snacks.
But we still do interesting work. This keeps going. We're committed to that.
a couple more here. Like the 4K versus 1080p resolution, were there any other unexpected technical problems you had to overcome from artist to screen? What was that part of the experience like?
Audio was a big thing.
Which
To
I'll
create
just quickly, sorry, Alex, I'll just add to that question. There's a question, how is the sound heard in the space? Is it quite clear? So we can kind of field those together.
Yeah, well, that was a big challenge. And it's a challenge because I want to underline that each works that we've seen, or in the entire class, everybody decided to do individual projects. So it's rather impressive to see all these animations. They take a very long time. For anybody who's done animation, you'll understand what I'm talking about. But everybody was doing individual work. So dealing with managing the audio is challenge. It was very big a challenge, especially if the audio was musical. So for example, we couldn't hear the bass properly. And then some pieces, that's certainly something in this context that we can learn better, how beyond the 4K, how do we work with these individual audio files that may have slightly different requirements. But other than the 4K and tech and the audio, the surprise was just the presence of the screen. That was the biggest surprise and the biggest challenge and the biggest opportunity. And it gave us the biggest excitement.
Yeah, and I wanted to bring up the little, like the lines between the screens, because it's 16 screens, right? The lines are very minimal, but they are still there. And there was one student that, literally used those lines to segment different pieces, but then most of the other students, we have a piece that goes over the whole one and basically try to ignore those lines as best we can. So like there's kind of that aesthetic hurdle to overcome in terms of the lines, and making sure that the really important elements is not on the in-between of the screens, because some of that might get lost, such as text or other aspects like that. So I would say that was a technical hurdle.
Yeah, and as this was an early use of the space, we didn't know that audio was going to be a technical hurdle. And I mean, that's something that we're addressing in the next iteration of the space, is making audio tuned to the space. The fact that there's going to be people sitting there, the fact that it goes past the hallway, like that requires a different dynamic sound. So it is a growing room for sure.
And that's also what we need to discover, and what a better way to discover as a group and class troubleshoot. Not just that the audio is challenging in terms of the infrastructure, the media infrastructure, but also in terms of the production. It's something we can learn in terms of balancing multiple projects in a unified space.
Yeah. One last question, and this one is to Jason. Do you find digital mediums easier or more effective when it comes to representing topics of gender identity compared to traditional mediums such as drawing or painting?
Yeah. Well, my master's research is literally about like animation and how that is an interface for exploring a redefined relationship between myself and my sister, as in the way that I am now, never existed at the same time as her. So that moving medium is very important to that relationship, because I can more easily explore ideas of cycles and growth and transformation. And I don't know if I would really have the ability to explore those same types of grounded in movement ideas with traditional medium. And personally, I love digital media, and I think that there's a lot of interfaces between different types of submediums. So like I can use video and draw on top of video, or I can use photography and you know, animate photographs. Yeah, so there's a lot of good little overlap there, and I just find that I am more expressive with the really subtle aspects of animation digitally rather than traditionally myself.
And sorry, we'll just do one more real quick here, but do you feel that such a large high resolution screen could facilitate interesting artistic collaborations? Example, imagine several individuals each had a tile of the screen and was given perhaps touch points at the four borders where they could interact with one another's tile, et cetera, et cetera.
Yeah, that would be cool. I think that there is a little game that some teachers are doing with Zoom, because you know Zoom have all the panels, and so you can have little games between the screens on Zoom, and that's like almost an early iteration of that. So yeah, that's super fun.
Yeah, it is a remarkably Zoom-like. So who knows what kind of work students will do after our pandemic experience. So the little squares gain just whole new meaning for us.
I just use these quick pictures here to illustrate that the thing we all share in life, and how subjective experience truly is. And Joel has used a term like the dream state sometimes, where you know it's indescribable some of the experiences we have using virtual reality or even in real life, and how to translate them to somebody else. And we know that when there's someone there with us, we've created a bond through experience that it really never existed before. And there's really no other substitution for that. And so part of the criteria that we tried to meet with the concept of our larger next stage of the facility was to be able to open up and democratize the technologies of the head-mounted displays, how to get a little bit past that. We started learning about different centers of excellence in the world that were using tremendous scale displays to allow one or more people to experience 3D media driven through game engines in real time, like Joel mentioned, down in the US. And it's a bit of a, from an AV perspective, it's a bit of a chicken before the egg situation, because you can do as many stakeholder consultations with as many disciplines as you can, and the person can describe what they want to achieve, but you'll end up with a laundry list of completely different solutions technically. So the challenge was to find a technical solution that could accommodate almost any dream that any new media artist has to build and display in our facility. I just wanted to make another note as well, that in the Commons building at the Okanagan, during the time of its construction, this is simply an idea on paper. The stakeholder process consultation was happening during the building being planned, and that when the construction was completed, we just had an empty room and a blank canvas. And so at that time is when we went down to the States to see some facilities that were in production, and we hired a company called Mechdyne Corporation that specialized in immense displays, especially augmented reality, virtual reality, extended reality. And we'll get to hear from them a little bit later. But we toured some of the facilities down in the States with one of their fellas, and he helped contextualize the trip for us. So very quickly, some of the more traditional experiences that we know that rely on heavy-duty AV infrastructure are projection mapping, as you've seen, those fine art applications around the world in public spaces where thousands of people are experiencing rich and lush motion and light and color and sound at the same time. We've had ultra large scale 70mm and larger movie theaters, projection systems over the past 30 years. There's an increasing use of VR enabled theme parks where there's a mix of physical and virtual stimulus there. And online gaming, I think, could be argued that is a shared experience as well. And I think, you know, with network speeds and the innovations with hardware and head-mounted devices, we're going to be seeing a more seamless experience, shared experience there as well. So I've mentioned the consultation with MECDINE and the discovery trip with 5 universities that Joel mentioned. And I'm just going to walk you through some of the setups we saw down there. And this is in the Hunt Library. It's not so much of the public facing, one of the component spaces they have. They probably have about 10 different audiovisual systems for use by faculty and researchers at Hunt. Some are public facing in the library, and some are a little bit behind closed doors. You can imagine the levels of support across the support staff and the technical proficiency required and the mix of skills that are required to support these kind of places. You can see, I'm not sure if you can see my cursor here. I'll try to turn this on. Oh boy, I hope you see it. We've got a lot of junk in the ceiling, and we realized pretty quickly that this format wasn't going to fit the bill for what we were looking for in our particular room. Big projectors, lots of fan noise, not necessarily the most seamless or impressive, really, wraparound kind of technology, but is very flexible. Many input formats, the ability to input many different sources at once. So you could send different sources to the different screens in the areas. And while we were there talking to the folks who run these facilities, we were just trying to draw out of them as much information as we could in these battle stories, and really try to understand the level of support that's really going to be required. So you saw in the previous pictures some projection, some direct projection display stuff that we're all familiar with. And then we visited the next site where we saw, again, not an entirely glamorous facility. This is actually a dedicated research facility that's built in an office space. You can see the drop ceiling, etc. But you'll also notice the people who are into VR, the light boxes on top of the truss work and this curved faceted wall, much like our Sawchuck Family Theater, nearly the same size as well, but it's got this curve. And what the curve gives you is kind of a sweet spot for viewing where you do feel a sense of immersion. And you can't see anything except the screen when you're standing in a certain position. And when the light's being projected towards you instead of from behind you, and because these are direct view displays, there tends to be just a vibrancy and a contrast that's available that we just did not see in the projected system. So at this point already, because of some of the physical things we didn't like about the projection, we started leaning towards the faceted displays like these things. Got 2 pictures here just to show you the kind of junk that's you're going to find behind the gear. This is like, you know, the stuff you'll see at stagings for concerts and this kind of stuff. And on the right, you'll see a whole rack full of pretty high-tech equipment. There's fans just huffing away, hot air blowing out, noise. It's in the space, actually, shared here with the wall. So it seems like a big science experiment, honestly, when you're in there. And didn't really have that environment that we were dreaming of for our own visualization and emerging media studio. This is Rowan University in New Jersey. And these are projection displays as well, but you'll notice there aren't any projectors in the ceiling here. This is all rear projection display. And it looks pretty good. It looks pretty good. Some of the problems here are, once again, the vibrancy and contrast that we can't reach with projectors that you can with these direct view displays. This one goes all the way to the floor, and it's pretty high as well. The design the that they kind of put a catchphrase on these types of walls. They kind of call them caves. In fact, they can be found out there in the world, especially in the UK and the US. They're nearly 360 degrees wraparound, and they just have a single panel where you walk in and out of the cave. They're completely immersive, and although they were very intriguing, that design, we just didn't feel it was broad enough to be able to accommodate every application and desire that we could offer, or that we could host for faculty and researchers across every discipline, because that's a very high arching goal of ours as well, is to be able to accommodate nearly any idea that somebody wants to try. A couple more slides there. And yeah, you'll notice in a few of these slides, and that Joel showed as well, it looks really blurry. And that's because we are wearing 3D glasses in many of them. And this is a modeling of oceanographic events and flooding events. So, this is an example of a data set that's been visualized over mapping information. And we're seeing this more and more in data visualization and scientific simulation, is drawing on real-time data that's out there in the world, being drawn from sensors integrated into other base layers of data. And it's some pretty heady stuff. And it's really where a lot of innovation is going in the world of information. This is a little exhibit that was created by the fellow driving it right here. It's more aimed at the public engagement. And that too is an avenue that VEMS is looking to support. It's one of the goals of the Library of the 21st Century movement is a higher level of community engagement to get people in the community to be able to benefit from the investments in the library. So this one here is more meant for the kiddies, and it's you can control with a hand controller where you place the bones on the dinosaur and build a skeleton back together. Another map one. I just wanted to show that for the scale. And this was impressive. It's a little more high tech. We got everything's blacked out. We got the blacked out ceiling and the rest of that, and we were getting to a place where we were getting pretty intrigued. This was like the size of a small aircraft hangar, and we don't have that kind of space in VEMS. So once again, we had to kind of diverge from this design. This is what it looks like behind the scenes. Not entirely glamorous. We want to provide the kind of experience that you'd find almost in a classroom. In fact, our interface for our studio is going to be a single touch panel, much like a teaching theater where you press a couple of buttons and everything turns on. It's going to be centrally supported by our AV team and our IT department. And so that basically, if there's any problem, it's essentially supported service, and it's not a kind of a mad scientist researcher who is the only person who knows how this stuff runs. You can see the space required behind a rear projection system and the amount of projectors. I think this is up to 10 or 11 or 12 projectors. I'm going to touch quickly on how we drive this many sources traditionally, and why we're working on a continuum of innovation, and you really can't just go to the store and buy one of these, is because in the days that everything we've seen here was developed and deployed, they were based on high performance computing clusters that were actually multiple computers that were synced together down to the millisecond. And it was tremendously expensive and had a tremendously high technical overhead to maintain them. And keep them tuned and calibrated. But in the modern era with NVIDIA's GPU technologies, we can fit as much processing into a single rack space server box that they could 10 years ago with multiple towers of racks filled with computers. And so our driver for our wall is going to be in a single rack space in one of those equipment racks that I showed you. This is a projected cave. Joel showed a picture just a short while ago of this one. This is a heavy-duty 3D molecular simulation. Joel's wearing a head tracking rig, and he is inside that molecule right now. You can't tell on this 2D picture, but the immersion is shockingly real. This particular model was not built for show. It is literally technically was living research, and was foundational in some discoveries about these types of polymers and their structures. And so when you get 2 or 3 mad scientists in a room together, interacting with something like this together, you really get some sparks flying. That's what it looks like with the projectors off. It's hard to believe that when in this older style of cave style of visualization, that once you turn those projectors on, the seams and the angles kind of disappear. And you start to realize how much reality, how much your brain really dictates how you're interpreting your environment. And it's not uncommon in situational simulation, such as firefighting simulation or law enforcement, to really see some increased heart rates, perspiration, and things of that nature, because it is fooling your brain into thinking that you're somewhere that you're not. And it's actually shocking how fast the grids that Jason mentioned on the wall, how fast those fall away. Then you become blind to those limitations, and you start to experience, again, some of that room back there and equipment. And we just don't have that kind of space in the VEM studio in the Commons building to be able to work with. So then further winnowed down our choices for technology and our selection. Big old projector. And some more gear. So these are some of the criteria. These are just only a few of the activities that we wanted to be able to facilitate in our studio. And I can tell you that across my travels and through my relationships I've built across Canada and the US, this is probably the most ambitious menu of activities that we've come across so far. And I think that it's going to be enabled because of the state of technology right now and the affordability of the screens and the computing performance, as well as the game engine's usability, and that's coming, it's just rapidly advancing so quickly. So digital exhibits from around the world, from leading institutions, the Smithsonian, British Museum of History. We're seeing libraries and museums create ultra high resolution digital exhibits, and frankly, there's no place to play them. We are building things like this for future generations to enjoy, but UBC Okanagan is going to be able to natively host digital exhibits from around the world very soon. Scientific simulation, this is computationally driven imagery and visualization that you're trying. It's an older concept, but you're limited by computing power, and we have one hot rod of a machine in this that's going into this room. It's going to be able to do real-time modeling of isosurfaces, which are things like aircraft wings and ship propellers and things that have a tremendous amount of dynamic forces, and be able to visualize that in real time. We're putting next generation video conferencing collaboration tools in there to try to meet the environments of modern day and advanced manufacturing processes, where you've got decentralized models of ultra high resolution AR overlays over a manufacturing, and production teams and manufacturing teams located in different places around the world. Your standard hardcore goals of experiential teaching and learning. So the very nature of this studio is experiential, and so we hope it's another arrow in the quiver for faculty that can take advantage and have that kind of vision to use a facility like this. One of the other basic scenarios is a decision-making theater, which they call, and that's being able to host in a time of crisis for the leadership of UBC to gather in the room and look at real-time data of emergency signage systems and essentially emergency preparedness, et cetera, in times of crises, as well as future planning for our university in line with the 2040 research goals here at UBC Okanagan. We're working with a lot of architectural plans and visions, and a display of this scale allows 10 to 15 people to experience architectural walkthroughs at a one-to-one scale of viewing. And I see a question come in from an attendee. Do you see this technology being used in visualizing architectural design? Precisely. And the magic there is the one-to-one scale. So instead of a couple of people huddled around a desk, it'll feel like you're standing in a room, and one person can essentially fly you through the entire building in almost one-to-one scale, which is just, it's breathtaking. So at the end of the day, this is what we came back with. 40 screens, just over 10 feet high and about 30 feet wide, with 82 million pixels, nearly 83 million pixels. A big demarcation here that makes our wall unique is that we are not scaling the audio, the video signal to the wall. And we see scaling, high quality scaling technologies nearly across the board. The capabilities of the compute that we've spec'd for this wall are going to run every display at its native resolution. So the techies out there who understand that native resolution means that you can walk up to this wall and it's going to be as clear as your screen on your Mac computer. And so with no apparatus on your face, you'll be able to have a really near field experience that's larger than almost anything you've ever seen before. And so that is really the progress update on this is that it's being assembled right now down in the US, and we're looking for delivery towards the end of January. This is a kind of just a 3D model of the room to give you an idea of the capacity. Before the wall goes in, we had up to 40 people in the space. Of course, COVID really complicates things. In fact, it has clouded our vision so much because it's hard not to, we're coming out of the end of it and we can look forward to some normality in the next summer here when we're fully up to speed with our programming. But yeah, it was hard getting to this point and then realizing that no one can stand in the room together. It was heartbreaking. But we're all confident we're going to come through the other side and we're going to build something great. And I just wanted to shed a little bit of light on the operations and the vision behind these two zones in the commons, the VEMS, what we call VEMS, the Visualization and Emerging Media Studio, which I just showed you the wall, and the Sawchuck Family Theater, and what Dr. Dulick mentioned about Joel's unwavering support. There's a layer in institutional technology support that's it's become increasingly obvious that we need expertise to support faculty and researchers like never before because of the demand for access to technologies like this. So with the recent restructuring of UBC IT Okanagan, we've got dedicated resources in place to not only launch this program, but to try to slowly grow with it and to apply resources as needed. And that goes kind of across the library. You can imagine the conversations when you're dealing with a place like the Smithsonian, trying to understand how to translate digital exhibits, of which there are no standards for production right now, to be able to take the data, shape it for our individual wall, and then find a way to essentially host it on display. And we're really looking forward to working on our workflows and the programming with the library staff in full partnership with UBC Studios, UBC IT Okanagan, and the Emerging Media Lab Okanagan. That's almost near the end of my talk. I'm looking forward to some questions, hopefully. I see another one come through for virtual presentations. Did you visit the Void in Pleasant Grove, Utah? It is now the 20th time I had to rejoin this webinar. Sorry to hear that, Kyle. It's a busy time of day, 4:17. A lot of people getting home from work. They tend to saturate Wi-Fi networks at home. But no, we did not. But thank you very much for bringing that up. We're going to take note of that. And right now, we are aggressively contacting any center of digital imaging excellence that we discover and try to establish relationships with the forerunners out there anywhere in the world that they might be located. I'll just wait for any other questions to pop in here.
Garth, there's a question that Jason had, wasn't able to type it into the, I need my mouse back, Garth.
Oh, sorry, go ahead. Is that the last slide there, Joel? I think it is.
Let's take a quick look. Perfect timing. Yeah, so Jason was wondering, in the case of the back projected screen example, what about the projector lights? Do you remember what the material was in order to diffuse the projector light? When I have a back projected on Lycra, the projector's light was so overwhelming to the actual projected images.
So sounds like you might be talking about hot spots. And yeah, it's there are very specialized materials used for rear projection, not terribly expensive, but you can see the architectural design that is required to make the frames to get the exact tension, the exact placement of those projectors, so you don't have those hotspot conditions. And if anybody's wondering, that's why you don't see an actual purely curved wall, because of the way that light works and the way that the photons travel. The part nearest you is going to be receiving the most energy compared to the parts that are a little further away. So the only way you can really get equal brightness is have like that flat surface, and that's why you see that slight graduation in the faceted walls. But it's a tough. I'm assuming maybe that you tried to make a home rig in the past, Jason, and it's possible. It's possible with some work, and depending on the kind of projector that you're using, yeah, and some are worse than others, I think. Excuse me. But I'll speak just a little bit more about the audio, maybe in the SFT thing too. Part of the support vision there for these special places is a real formal, iterative loop of consultation with users and applying changes literally throughout the academic year. For instance, Joel and I have a list as long as our arm of technical improvements that we are going to apply to the SFT directly from the feedback from the work that he did with the class through development and playback of their pieces there. So we learn how to do our jobs better by working more closely with faculty and researchers, and that is the language we speak, and that is those are the goals we're trying to meet. In fact, it's a new age as far as of advanced support for emerging technologies. Historically, in some of the bigger libraries in the world, you just didn't have such sophisticated systems that needed ongoing maintenance, and also that interpretation when someone comes into a space and says, "Here's what I want to do." And for someone to have the technical wherewithal and the artistic or the creative sensibilities as well to collaborate with a client, to meet them in the middle, to be able to translate the technical shortcomings or the technical potentials of the venue, and then help them reach their goals. And so that's what we're trying to build as well into our consultative process.
And there's no questions at the moment, but Alex did comment that regarding presentation spaces for media work, that there are so few public opportunities to show immersive media locally. The large display spaces at UBCO are really, really critical for our students to be able to build and practice for such displays. Do you want to just talk a little bit about that for a second?
Sure thing. We know that the University of Calgary has recently built a wall. University of Alberta has built a smaller wall. The University of Toronto put in a wall last year. I was at Concordia University in Montreal. They too have installed a wall. So we don't want to get caught behind here, and we want to offer our students world-class experience on some on world-class equipment, and we're well on our way to doing that. And we just can't wait for new groups and new semesters of users and students to come through the spaces, use the gear, and have those ideas lead to the next and to the next, and really build up that community of high-powered media artists and emerging media artists.
And we have one more question that's come in. What is your strategy for input to the setup? Do you think using 6 DOF controllers or the like has value?
Absolutely, absolutely. We haven't, we're trying to build such an open philosophy to the system that human-computer interaction is actually a very high priority for us. I know that, as Dr. Dulick mentioned, initially, a software set, a Max MSP, was bantied about, talking about making a computational media production kit that's actually very unique to the Faculty of Creative Critical Studies here at EBCO. And it was their ambition to actually really start doing human-computer interface in this space, the SFT, which she alluded to. Now that's kind of public facing, and we can do that. We're open to it for sure. In fact, it's one of the most intriguing areas of truly interactive computational based media. It's super exciting. In the studio though, in the VEM studio, we've got a raised ceiling which has a complete studio grid. So very, very quickly we can, it's all full power and data as well in the ceiling. So we're going to be open for people plugging all kinds of devices in. We've got music inputs for musical instruments. We've got multiple HDMI inputs at 4K resolution. We've got wireless inputs. We've got, on top of the truss, we've got all sorts of potential for motion tracking systems, temporarily or permanently installed. In fact, we're at the stage now of maturity where Joel and I are actively contributing to grant applications because the granting agencies they favor collaboration with other units at institutions. They know the value that it can present and the interdisciplinary potential. And so we're actively contributing to grant applications. And I can foresee in the future of layering other technologies into the space that we just couldn't afford to do now. And that's one of our other ongoing goals. So definitely every kind of sensor and every kind of controller we're looking forward to try to integrate them and play with in the space. And including spatialized audio, true spatialized audio. We think it's going to become very important. So we've got a relatively basic ability to create directional audio. When we open the studio, it's designed that way. But we'd like to emulate Concordia University's example of a true audio dome that will surround the users. And we're talking 20 to 40 or more speakers that are completely assignable and imageable for beyond rich stereo sound. So for talking about immersion, yeah, anything and everything, just send us an email.
As the software solutions architect, kind of my role is one where I'm interacting with kind of among our sales team and our clients and our internal engineering team, as well as the existing clients that we have. So a lot of conversations of hearing what challenges people have in terms of the experiences they want to create, the different use cases they have across a number of different disciplines and fields. So it's really exciting to just to see the variety of different types of things that can be done with this technology. My background is one of computer, kind of a combination of computer science and art. And when I was looking at different areas that combine those interests, when I found the virtual reality systems and particularly the Cave I mean, almost over 22 years ago. It was really exciting to the first time we would step in and see this virtual world just all around me as we then network these together around the world. So I joined Mechdyne full-time in 2007, but then I've been working here going back to 2001. So the different hardware technology has changed a lot, but it's amazing to see just how much more accessible and how powerful the tools are to now create the experiences that can be done in these systems. As I described, the system that we're going to be putting together there for UBCO, this is a big display. We've got 40 LCD panels. And an interesting aspect of this is that the way these panels are set up, they can support both immersive VR with stereo and full interactivity, as well as a classroom presentation use case with 2D input. So that really broadens the usefulness of this system and being able to support a number of different use cases. So the 2D use case can essentially be treated as a large screen for presentation. It's like a really big desktop. We've got software installed to help manage that big of a desktop. So in terms of tiling different displays or tiling different content, whether it's videos or other applications, and then it can also be switched to use for a full 3D mode. So in the 3D mode, you've got a fully immersive 180-degree wraparound visual experience that completely fills your field of view. For the 2D side, we have a solution called Meeting Canvas. So this is a kind of a collaboration software designed to manage a very large desktop space. So we put this in place at a number of different places. You can bring your own devices. So you can, for example, with your phone, you can, if there's a picture or something on your phone that you want to discuss with the group, you can easily just flick and send content from your own devices to the display. Makes it really, really powerful as a meeting space, and can also be used for particularly for VTC meetings and having groups come together. And another part of that is a very high performance remote desktop solution that we have. So that's going to make it very easy to, without having to follow cables around, but just to directly connect over the wireless and send a high performance remote display of your own devices into the system for doing remote desktop presentation. And then I'm going to be talking about the 3D aspect using particularly the Unity game engine to easily create visual interactive experiences on the system. With any big display like this, the important thing is being able to use it. So what we don't want to have is a system that's turned off. There's no return on investment for a system that's powered off. We want systems that are so heavily used that students and faculty and staff, everybody has to compete for time on the system. So at the large display and big real estate, the important thing is just being able to invite people to come in and to have the tools and capabilities to really create whatever anyone can imagine, and to put that on the system, create the experience for the users that come in. So we look at what is VR. So I mean, it's been around for a long time. Now there's different, more accessible hardware that can bring you consumer level headset displays, and Garth put up the displays of several of the different types of systems that they visited. But in virtual reality, the key is the screen is your world. It suspends your disbelief as you're looking in the virtual environment. You've got a high quality of display fidelity, high level of interaction, so you're very, very engaged with what you see and what you hear, what you do. So it creates a very rich sensory experience for anyone in an environment. And it's amazing to, I'll talk to one of the examples for one of the sites that how quickly, once you go into the system, any of you really feel physically transported into the virtual environment. So currently there's, I mean, the technology has been around for over 20 years. Displays have changed, the computers have changed. Instead of no longer having the big high-end workstations, supercomputers, now you've got smaller, either the clusters of commodity PCs or really big, powerful workstation PCs that we've assembled, like the one that could be driving the system here. The applications can be very specialized, but particularly within the industry, there's a big focus on getting return on investment. So big systems, they're complex, but there's very exciting stuff that's being done around them. Head-mounted displays have been around for a while, and now we've got higher resolution that's available. So they're lower cost. You can run them from your desktop, single and multi-user. They make it easier to experiment with VR and 3D interaction. But wearing something on your head can be tiring. It can be short use. Also issues with comfort, and now also with hygiene, being able to share headsets. You're also cut off. If the user's wearing a headset, you're cut off from collaboration, gesturing, taking notes. It's generally not a direct collaborative experience with the other people directly there in the room. So large-scale displays can be scaled to customize for multiple users, and that's a key thing as we've talked with our clients. One of the biggest things that drives large display systems is the ability for face-to-face interactions among groups of people to actually talk face-to-face as they're looking and sharing in the experience and what's being presented on the screen. So motion tracking is a key part. There was a question on that with what motion tracking brings in. So you've got tracking a head point as the user moves around. So then anywhere that you move through the space, your position is tracked. You can control navigation and interaction to directly interact fully three-dimensionally with the scene around you. Be integrated into the HMDs and the display system. This makes it easy to dive into really complex data. Very natural navigation. You can point and move to just navigate through something. Picking up and moving something is also very intuitive. So it compounds the kind of the benefits of the large display, 3D interaction, and tracking system to give an engaging visual and interactive experience. Why do all this? It can be doing stuff in VR can be safer than the physical environment. It can be used for things like simulation and mission planning, interacting with hazardous materials or hazardous environments, things that could be impossible to explore by other means, so things that have a very large cosmological scale, a very tiny nanoscale. The sense of teleimmersion with having collaboration of multiple people, bringing in design review. We've had manufacturing clients that have identified manufacturing defects that they visually caught by the quality of the visual display, and they were able to catch that during the design stage before anything moved in manufacturing, and that saved them several tens, hundreds, thousands of dollars. It's also great for marketing. For non-experts, being able to sell products or research and just communicate and tell stories. And also, it's just the pure enjoyment and being able to use these for art and emerging media. Being able to have students come in and create content is just exciting. It's always great when we look at the output that students have done in student competitions at their universities. It's great to see the creativity and the engagement that goes into what they make. And some of the challenges that come up in using these displays is that the hardware can be complex. There may not be off-the-shelf options to easily support the configuration of displays. Development can be hard, and users may not know how to get started. Well, about 10 years ago, we were in the process of creating a kind of an interactive platform for systems that we were delivering to our clients. And so one of the examples of this was this virtual shopper for a client that was coming in and doing a virtual shopping of their products. And we had to do a lot of model loading. We added physics. There was customizable scripting. And as we went through all this, we realized it was a lot of work for us to create and manage all of this software capability ourselves. So instead, we need to use off-the-shelf game engines that have all of these capabilities already. We can bring in models very easily. We get higher quality colors, rendering, all the hierarchy and metadata information comes in. Get higher quality photorealism, ray tracing, and more importantly, get the ability to have really dynamic characters and behaviors. And so we turned our attention to using the game engines, which made it easy for us to bring data into the system, into the game engine. We still had to do some development, but the programming resources was very different for using a game engine versus low-level C and C++ development that used to be done years ago. And so Get Real 3D is what's going to be delivered on this system, but it's really just something that we made that let us leverage what was already available with Unity to create and author content. And so that meant we could really create anything that we wanted using the game engine and the tools that it has. We could develop simulations, the physics are already there, kinematics, the VR tracking and controller use, we were able to bring that in. And so it reduced all the complexity of putting a complex interactive experience on a cluster of PCs and to manage the synchronization. We chose Unity because it was a really powerful engine, had a great engine for doing real-time rendering, get high quality lighting and materials, dynamic terrain, physics and kinematics, audio. There's a visual editor where it makes it really accessible to create and control the experiences. And now that can be done without writing any code. There can be effectively drag and drop of components into a scene to set up the behaviors. There's also a very large user base, so that makes it easy to bring in external assets. So there's an asset store where you can just go out and, including free assets, just download different components and different features, whether it's models or script behaviors, to import those into the scene. And that's really powerful because that means even though looking to create experiences on a large VR display system, we're able to leverage this entire community that's out there that has just a tremendous wealth of other content available to use. So the editor, you can easily do things like create 2D interfaces, bring in models, and so I'm going to walk through some of the different things that we and our clients have also put together. So, for example, here's a view of a manufacturing robot running within the editor. So it's a really visual, direct interaction environment. And then when it runs on the system, this was just a simple 2-wall staging system. All the animations, everything else, all stay in sync among all the displays. For architecture, there's a bunch of workflows, and actually now there's some different tools that automate the workflow of getting data from Revit, Navisworks, and Rhino directly into Unity. This was a case we were doing an evaluation on an apartment building. So there's the model on the left, and then on the right is the user actually experiencing it in the cave. As we were walking through, we were checking the bulkheads and clearance through some of the entrances. This was another system that had a reconfigurable walls that actually open and close. So being able to do that let them kind of change based on which space they were evaluating for their design reviews. They would change the display configuration, whether it was more of a wide open space or something that was tighter. Seeing everything at a 1-to-1 scale allowed them to do the walkthroughs and just visually catch where they needed to make adjustments. This was another system, the UIC Cave 2. This was a 36-node system. This was the cave at Iowa State University. So they did a project where they were showing off to potential football recruits what it might look like as they walk out on the football field. And so using the game engine, they actually had the stands the crowd in the stands were animated. The football players that came out on the field moved through formation. So all of this kind of dynamic behavior that they were to implement with the game engine made it just a more seamless experience of actually having, not just looking at a model, but really engaging with a dynamic virtual world around them. Another university did a firefighting simulation where the gaming program students actually worked with firefighters locally in their community, and they created this simulation where the overhead rafters were on fire, and so using a mock-up of a hose, they had to aim at the correct direction and pressure to extinguish the fire before the rafters would actually fall. So the engine provided the burning and all the internal simulations to create the behavior of the building burning. We did a cruise ship event a few years ago where they had the model of the ship, and they wanted to do a big unveiling of this vessel, but I guess about 3 weeks before their opening, the CEO said, "Well, I don't want to just look at the model. I want to actually, when I'm up on the roof or on the rooftop garden, I want the plants to have the leaves blowing in the wind." he wanted to have the sounds of the band playing. So we came in, and using Unity, we were able to do both of those. So the plants would blow, the band would play. There were actually people that were walking around on the pool deck. So instead of just walking through a CAD model, we were actually walking through a populated, busy ship with people walking around the pool. You go into the restaurant bar. There's a bartender serving people drinks. So all this kind of just created a more dynamic environment. They also wanted to do things with a dynamic configuration, where the lower left there was an artwork down in an interior part of the ship, and so using the game engine, we were able to set up a user interface to just quickly cycle through different iterations of that artwork, so that they could look at and compare what they wanted to look at. And the sense of presence can be so strong. So the CEO he did the first walkthrough of the demo. Of course, he'd been running in this system for the entire week, so he had the speed turned up really fast on the navigation. So we're up on the outside of the ship, and then he quickly zoomed down into the interior, and everybody that was visiting who hadn't been here screamed and ducked as they flew into the ship. So we let someone else drive the rest of the day. But I thought it was a great example that for everybody that was there, as it looked like the bulkheads were flying right into their foreheads, that just seeing everybody that was standing here just all duck in unison, I thought was a good indicator of just how strong that sense of presence in the environment is when someone's experiencing something in these. We've also done a multi-user system. So if we consider multiple caves kind of connected together, we can use the game engine to leverage multiplayer capabilities. So they could actually go into a collaborative experience going through a training scenario. We've used oil and gas is really big on safety. So being able to use the engine to create simulations that let them explore and train on hazardous situations without any exposure is really important. So we did. There was a project where we were creating a training scenario for a gas plant leak. So there's a liquid leak in the oil plant, and the visuals were really what the subject did in the environment was not as important. What was important is that this training was actually about their audio communication. So they had a microphone, and they were talking with it's like a desk operator. And so they had to radio back in the correct sequence with the correct acknowledgments of what they observed through the environment. And so being able to do that virtually meant we could change the environment and just kind of script the sequence of events as they go through learning the right things to say and respond. Another use case we had was a safety inspection for scaffolding, where users would have to actually scan with their head to look at certain things of the scaffolding to verify whether it was correct or not. So the things, for example, in the upper right, they'd have to check to make sure that there was a wood block under the base of the scaffolding. Or in the lower right, they'd have to verify that the ladder is properly attached to the scaffolding. All of this was based on being able to train their eyes and to move their head in the correct direction as they looked at the display. So they'd actually look up and down, because these all mimic the behaviors that they would need to do on a real site. We also created a fired heater shutdown. So the important thing when doing a shutdown for a heater is that if the right sequence isn't followed, then it can actually cause a flashback, and that burn is really dangerous and can kill people. So using scripting the behavior lets them actually go through and dynamically create the sequence of going through that shutdown. One of the exciting things with this was that we actually had some additional monitoring in place to monitor the heart rate and see how they responded once they were given the commands. Also been doing experimental projects with using the game engine. So whereas we used to have to use customized software, now just using the game engine, we can connect these up with robotic simulations, other components that will actually do additional monitoring. So with the motion tracking, we can track where the user is, where the virtual robot is, and this was a case we're actually studying they're studying the proximity between the participant and the virtual robot to try to get an assessment of, is there a level that they start to feel uncomfortable. We've also been doing a project looking at a construction site drone safety. So as an aerial drone approaches subjects standing in the environment, we have a force plate on the floor, so we're tracking where they, as they move. We can actually measure and feed that into the environment to measure their loss of balance. We also measure their heart rate, and this lets us collect the data and determine does the drone fly too close. So the game engines are being used a lot for creating content for design decisions and manufacturing. Bringing the content in lets them see the environment, experience kind of the visual placement of stuff. And the large display makes it easy to have multiple people all in there for cross-functional collaboration. And this lets the interaction among the team really flow. And that ultimately leads to improved workflow as they can actually assess the ergonomics in factories, plants, and work cells. And so with the hybrid environment, you're going to be able to actually drive all of these at the same time. So doing 2D interaction, for example, on one side and having 3D on the other, there's just a blended capability of what can be done. And so really the invitation is just to consider data-rich storytelling. What are the stories that you have to tell and want to present, whether it's educational concepts that have complex 3D structures, digital heritage, training and simulation, arts and communication. As you just look at all of the different things insights, whether it's experimental research, design reviews, different collaborations. Using these big displays and the engine and tools that are available just give you more ways to engage, visualize, and interact with the content. So it's exciting, and there's really just no limit to what you can do. So that's kind of a quick overview of a lot of the different types of works that we've done. So I've opened up for any questions. Thank you.
Thank you very much, Chris. We do have a couple questions here. The first one is, with the use of Unity, do you think that non-technical people can also participate in the development or maintenance?
Absolutely, and that was our primary reason for where we've had the turn off the sharing. Our engagement with Unity has actually been primarily centered around exactly that fact. The development in Unity can be used either with JavaScript or C#, but there are visual tools to create the interaction without doing really any code. And so that's been, we think, one of the biggest benefits of it is just the accessibility of Unity's development just makes it broadly applicable across a bunch of disciplines.
And how does Mechdyne facilitate the collaborations between the technical team and the client's subject matter experts? Can you share some best practices?
It's really just having those conversations. So getting everyone involved openly in communication. One of the common things that we've run into just from a business standpoint, if there's one group, for example, driving, or I guess the purchasers of the system, but then ultimately what we always strive to do is make sure that we're talking to everybody that would be involved in running a system. That means who are going to be the people that have to turn it on and off, and making sure that a client has resources to do that. Who are the professors that actually want to drive content on the systems? Which content do they want to drive? Can they? We often work during our process to get demo content, so that when we're, for example, when we're creating a system for a client, that we can unveil it and make it possible really to hit the ground running with content that's relevant directly from you. So we always seek to get sample data from the professors or from the students, so that it's really just making that communication open and talking to get the data and just experiment with it, visually explore what can be done. One of the nice things with Unity is because it can be so quick to develop and show something. We try to really just push on the iteration, just trying something, experimenting with short, small steps, just to constantly get something out there and get feedback.
And I think at the moment, that's all the questions we have. If anyone has another question, oh, one has just come in. How do you deal with visualizations of abstract 3D dimensional data in a rotating space? It is a challenge in one of our projects right now to make something like this.
So if it can depend on what type of data. I mean, if it's point clouds, there are ways. I mean, points can be splatted at a certain size, or if you're creating isosurfaces. I mean, we'll utilize, for example, ParaView as an open source tool. We'll use that a lot for if there's actual data viz that has to happen, and then we can bring the visualization output into Unity. I guess I'd have to. I want to know more about. If you can tell me more about what that format, what the data actually is, because that may lead into how you would actually visualize it.